Okay, so let's have the demonstration in that we are supposed to have on image representation. And in this course, we will use Python. So the very first one that we are interested in to see that how to do the image reading and image showing and how to understand image data types. So the provided the background that we had, so we are presenting this one. So first you need to understand the theory behind, and then you come up here. So then it will be good for you for understanding. Okay, so this is basically Jupyter Notebook. If you see that in some of you are already familiar with this programming interface. So here we will write our program, and they who don't know, so you can know that how to install the Jupyter Notebook from different sources. Perhaps you go back to YouTube or somewhere. So for example, what you need to do is like this page. Last time I taught that how to install the Python program in image processing course or somewhere else, also in probability statistics. So here, you will first install Anaconda in your computers. So for that, you just follow this link, and from here you can install Anaconda. So depending on your systems, you do that. Now after you install this, the first things that we need to do is we have to install some sort of package for Python. So to install the package, you need to start. Once you install Anaconda, then if you go to your program, start menu, and somewhere then you will see that something like Anaconda prompt. Okay, so this Anaconda prompt, and using this Anaconda prompt, we'll have to install the very important Python packages. So Python packages, if we install, then we can use that Python package for our different command or code. So some of the very important packages are Numpy package, SciPy or SciPy, Matplotlib or Matplot library, Pandas, scikit-image, and scikit-learn. And the installation is very easy. Once you run this Anaconda prompt, then you will be coming up with something like this DOS prompt screen, and then there you just write pip install and then your package name. For examples, here we are installing the first one is Numpy package, so that means pip, that is pip, or we say Python package installation in Python, or Python installation package something install, and then you just give Numpy and then it will be installed. So similarly, you install for SciPy, Matplot libraries, Pandas, scikit-learn, scikit-image, so and so. Now once you do so, then again you just go to your starts menu, and then these times you basically launch Anaconda Navigator. Okay, so if you open the Anaconda Navigators from your start menu, and then you would be coming up with these sorts of interface, and then from here you can basically run this Jupyter Notebook. Here you see the Jupyter Notebook, not Jupyter Notebook Lab. We are basically interested in Jupyter Notebook. Okay, so once you launch this Jupyter Notebook, then you would be coming up with this kind of interface, more exactly here kind of. Then you can open file, or you can create folders. For example, if you go new, then you can go new, create folder, or you can create new Python code, something. So similarly, I created one new file, and this file name is, I gave this image representation, and then let's restart somewhere. Now in the beginning, definitely we need to import some important package or useful package that we need. Every time we use a command or something or some function, so then we need to see that function, where this function is coming from, which package. So definitely some functions are coming from Numpy package, some functions are coming from scisk, image or scikit-image package, and some functions are coming from matplot library, or some are from pandas, scikit-learn, so and so. And while we go through and you learn Python and some other of your elements that you need, then you will be understanding that what packages you need to and what kind of functions you need to. So those things. So anyway, for this lab, for these demonstrations, we'll use something like Numpy package. So just we are importing Numpy package, and because Numpy is a little bit longer, so we can rename this Numpy package in shorthand like NP. So that's why we write we are importing Numpy, and then we are saying the Numpy as NP. Okay, so this is that one. I'm not explaining the Python itself, so please understand that for your clarification and understanding on Python, you need to learn it yourself. Anyway, so we import Numpy and then we rename it as NP. And also there are another very useful package to deal with, to work with image in Python, that is called scikit-image, or we say sk-image. Now this package itself is very large and very deep. It has many modules, submodules, those things. So one module within this scikit package, scikit-image package, is data module. So what we are doing is we are first from this scikit-image we are importing data module. Okay, so one thing we can do, we can just import the entire package. So in that case we write import this package name and we can rename it, or we can just import some specific module from a particular package. For example, this one from scikit-image we are importing data package, data submodule or module. Also we import matplot library. Within the matplot library package there is a module called pyplot module, so we are importing that. So import matplot library.pyplot and we rename is plt, that is plot. Okay, now let's say first we we will work with an image and we see that how to read that image. Now one very good thing is that in Python it comes with, especially this scikit-image package, it comes with some built-in data, built-in image. So and that built-in image basically is stayed and contained within this data sub module. So that's why we write okay data dot camera, and then this sorts of format if we show, then what it does is it basically import that this camera data, and then we place this camera data with the my image variable. Okay, so you see here is a very simple, just these data means actually this is coming from these data. Okay, data, and within this there is a camera image. So and this camera basically an image, and more appropriately this image is stored as a Numpy n-dimensional array. Okay, so this my image now contain our cameraman image. Okay, and so the read function is done. There are other way to read the image that we will see shortly, but this is how it is. And then let's say we show the image. So to show the image, this is basically we use for plotting purposes, this matplot libraries, this package. So what we do is this plt dot image show function, and if we write the image show and then we just pass that the image data, and in this case our my image, this variable itself is an n-dimensional array because our data saved here in this my image. So my image, and if you just run it, then you can see this sorts of image. Okay, so this kind of image I already did this, I already run this, but you will have to, for example, if you run kind of this kind, so you just coming up with this kind of things. And here this image is basically we are saying that okay, the color map is actually gray, even though it's a gray level image, but it's still possible that you can assign some color map. So color map for gray level image basically reflect that which pixels have the similar intensity, then based on that it shows some color. But if you already read the color, we don't need to show the color map. Just write the color map equal to gray, so it's perfectly gray image we can see. Okay, so now then you see what we would do is we see that what is the type of this my image. Okay, so this is the type of that my image. If you run it, then you see this is an n-dimensional array. Okay, and this is Numpy n-dimensional array. So, and if you like to see the shape, that what kind of shape, if you run it, then you see this is basically 512 by 512 array. So that means it has 512 rows and 512 columns, and this is exactly, we can see that, for example, if you see that this from 0 to this 512, and from 0 to 512, this is what it is, right? So this is very interesting. This first 512 that we are seeing is this one that we can say maybe row number, let's say, that is goes from 0 to, and this 0, it starts from here, and this 0 start from just here. So that means 00 pixel is basically the very first one here. This is the 00 pixel, not this one. Okay, so you have to understand this, that this this one, this one is basically 00 pixel, not this one. Okay, and then you go the next one in this way. So this is how we need to understand that how image is represented in Python. Okay, and then let's say we go that to say the shape. So we understand this is 512 by 512, and let's say what is the first pixel, that is the 00 pixel. So what we can do is, you see, the my image is our image data that we saved, and if you just write the 00, just give any pixel location. So here in this case we just give 00 location, and if you just run it, then you will see this is basically just run again, and you see this is 156. So that means the very first pixels level, gray level, is 156. And you know that the pixel values for a gray level image, if we have a 8-bit image, so that means each pixel level might be from 0 to 255. So that means they have 256 different levels. So that is it. Actually, even you run it like this one, that let's say we try to understand the types for even the very fast pixel data. That means one particular single pixel data, how it looks like. So if you run this one, this type my image 00, then you see this saying it is a Numpy element, Numpy object, and this is basically an unsigned integer 8. So that means 1 byte for each pixels there, and that is the same understanding that we had from our theoretical discussions. Okay, so there is another way that how we can show the image, and let's say in this case we have a color image. So what we can do is from this scikit image package, we can import this IO module. So and Numpy is as it is, and matplotlib library as it is, the same setup that we had. And now this time, let's say we write this IO, that is input and output dot imread, means image read, and then you just specify the path of the image that where you keep in your computer. So this is the location where I kept my image, and this image is basically lena.jpg, and to show the image, just we write io.imshow. So that means this IO means this IO, input output, then image show, and then you write the lena, and then lena means this image, this already we read this image and we keep in this within this one, this lena, right? So lena basically now contains this image file. So if we pass this argument to image show, and if you run it, then you would see this the color image, that lena image that we already saw that, right? Okay, now if you like to see that what is the type of our this image, so write type with the same code and just write the type lena, and if you run it, then you see it is an n-dimensional, again an n-dimensional Numpy array. And then if you like to see the shape of this color image, if you run it, then you see the shape of the image is basically 220, 223. What does it mean? It means if you remember that for color image we have a 3 plane. One is red plane, and then green plane, and then blue plane, and each plane is basically a 2-dimensional structures, right? So same, you see, this image is basically, has 220 rows and 220 columns, and there are 3 such planes. So that's much simple. So that means the very first plane, that means let's say 0 plane, this 3 is basically 0, 1, 2, 3. 0 plane is red, and 1 is green, and 3 is basically blue. Now let's say that red, green, blue, and those we see it. Okay, so first of all, we understand this Lena is our image. Okay, this Lena image. Now see that we will access only the red channel. How we can do so? We can keep all the rows and all the columns and just for 0. See, when we access a particular element, so we write this kind of things, right? You see the third bracket, this third braces we give. So, and this means that we are particularly accessing a particular location. Okay, so essentially what does it does that you are just saying that show my image and represented by this one. And what is this one? This Lena, it will show all the rows, all the columns for the the very first plane, and the very first plane is basically the red plane, that we say this 0. So then if we run, then we will see that this is the red plane. And if we just write the 1 instead of 0, so just this indexing, if you just give 1, so that means it will be green channel. Okay, this is basically the green channel. And if we give 2, that means it will be the blue channel. So this is how it is, right? So it's the same setup and code we are writing, just we are accessing red channel and this green channel and the blue channel. Of course, if you notice carefully, so this image basically is different, right? So, and this is with a red channel. This is not the red component image, not red plane image. This is rather it's a red channel. And I explained what we mean by channel. You go back and check it. But it is good to see that we like to see the red image itself, not just channel. So if you'd like to see that, then we need to do what? You see that again, let's say we first read the image Lena, the same we do, and then what we do is, let's say I mean this what is this this line? It tells us like this one. It's saying that keep these all rows, all columns, and for the green channel, and make this value is 0. So that means all the pixel values in all rows, all columns, that means all the pixel values for this green plane make 0. It means so. Similarly, we also make all the pixel values for the blue channel also 0. So if we make this green value 0 and the blue value 0, that means all the pixel values for the green planes and the blue planes is become 0, and we don't change for the red one. Okay, so this means inactive, so we don't do that, we don't do anything. And then if we show the Lena image, so that means ultimately what? This Lena image now doesn't contain any green part and the blue part, only it has the red part. Now if you run it, so you see, that's why we see a red kind of image. So it's kind of a level image over the red shade, right? So, and each pixel how much red is there, so this means that. So similarly, if we just do this sort of things, that make red, all the red pixel zeros and all the blue component zeros, so you will also only have the green component one. So that's it. And similarly, if you just do the other one, that you make the red component 0 and the green component 0 and keep the Lena, the blue component intact, so in that case it will be looking like the blue color kind of things, right? So this is that much simple actually. Okay, now let's explain that image histogram. If you remember that we learned the theory and concept, so now we are demonstrating the similar things in Python. So we will see the image histogram, and I explained what is that. I explained already. So the same setup, the same code that we write, that let's say we have numpy and np from scikit image import data, import matplotlib pyplot plt, and then we just take our cameraman image that we had in the beginning. And this times, let's say what we do is, like let's say first we we will show the image, and then we will also show the image histogram. So that means we will try to present two figures, the figure 1 and figure 2. But it is also good, let's say both figures we just draw in the same panel. So that means we will be doing subplotting. Now to do the subplotting, it's very easy. In Python, in Matplotlib, if you import Matplotlib library, then you can easily do this subplotting. Now for subplotting, this is the structure how we write it. So let's say fig. So fig means figure, and then comma, and then you write the how many plots you need. Let's say we will have 2 plots. So just so this is that's a plot dot subplots, and within the subplots we write 2. So that means this particular command, that plt, that means this plt dot subplots 2 means it will produce 2 subplot. Okay, two subplots. Actually it will create 2 empty block where we can actually draw our figure. So it will create a space within a single figure space. It will create 2 division. So that's what it means. So this is that one. And now you see, and then the one plot, let's say we just say this axis is ax1 and the other plot axis is ax2. Okay, so in the ax1, so that means in this axis we will show the image, our image, cameraman image, and the cameraman image is basically we already kept with the my image variable. And you can turn on this one, that cmap is gray one. So what it does is this ax1 in the very first subplot space, it will show this cameraman image. And in the second axis, let's say ax2, and then you write dot hist. So if you write image show, that it will show the image, but if you write hist, histogram, then it will show this histogram of this my image. Okay, but this command, this ist histogram, is basically it takes this histogram command want a very one-dimensional data actually. Okay, so you can do this my image basically 2-dimensional data. That this is because this is a cameraman image we already saw. So what we can do, we can convert this 2-dimensional data into a single row. So to do so, we use this flatten command. So flatten command means all the array size, or whatever the array size is, all the elements will be coming one after another in a single row. So that's why we write the flatten the array size, whatever. And then so what does it does that it only contains a one-dimensional numbers, and definitely this one dimension, how many numbers is there? Do you know that? Because it has 512 rows and 512 columns, so the number of elements now becomes 512 by 512, this many. So this all of this a sequence of data there are, or a collections of data. Now we can make the histogram. Now when we make the histogram, so how many groups we will create, how many bins we will create, so that depends on us. You can create bins equal 20, 10 something, but let's say we just create 256 bins or something. Or more appropriately, we can calculate something like this. Let's say from here to here we create a range. So when we create this kind of things, let's say we call this numpy package, that np, and there is a range function. Then from this number 0.5 to 256, within this number it will just create some equally spaced and increasing, each one increased by 1, that is 0.5, 1.5, 2.5, 3.5, 4.5. it will create a range. Now each range can be treated as a bin. So this is that means. Okay, and what would be the histogram color? The color is, let's say, blue. Okay, so if you run it, so if you run these things, so you see the very first one, that axis one is basically your image show, the cameraman, because this image now showing within the single figure, so this image now become a smaller size just for display, but the image data is the same that as we had. And this is the histogram, and the histogram now tells us that what is the pixel distribution. We can see that the pixel values somewhere between maybe 5 to maybe 10, So there are some substantial number of pixels, and this is basically the blackish, and this is actually this black part pixels are this one. Also it has somehow like above 100 to up to maybe 160 or 70, that kind of pixels levels. Also we have something like this one. You see the whitest part it means, but there is no perfect white because you see these all are 0. So this is somehow showing the histogram for this gray level image. Okay, now let's say we see the histogram for the color image. Now you see for the color image, now we have 3 plane. One is red plane, one is green, and one is blue. So for each 3 one, we need to draw the histogram separately. So we read the Lena image, and this Lena image, you see, first of all we need to separate out the red channel, green channel, blue channel. Let's say Lena red is one variable, and Lena green is a variable, Lena blue is a variable. You can write, if you have multiple variables, you can write one after another using comma, 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 and then you just keep like this. That's Lena all row all column for the red channel. So this red channel will be actually now stored into Lena underscore red variable. Okay, so then you can just show the image. So you just show image, the red image, and so on the green image, and so on the blue image. But here we created a subplot, because here we have 3 images. One is red, green, another is blue, and then we also have 3 histogram that we want to produce. So total 6 graph we want to produce, and let's say we'll show it in a subplots basis. So how we can do that? So we have 6 figures. So let's say the first rows we will place the image one after another, and in the second row we'll keep the corresponding histogram. So that means we'll have 2 rows and 3 columns. So we can just produce subplots 2 by 3. So that means it will produce 2 rows and 3 columns. And let's say all this axis name is contained within this AX. So that means the very first axis is location is AX 00, and then next one is 01, next one is 02. If you let's run it, you see. So there are 6 subplot, you see. So 1, 2, 3, 4, 5, 6. The very first one basically is 00. So in this location we just show the image, the red channel image. And the second one is basically this one 0. This is 00 location. So this one is basically 00 location. Okay, and this one is 01. This is 02. And similarly you can understand that this is 10 location, this is 11, and this is 12, right? So this is that red one, and this is in this location we just plot its histogram. You see the hist Lena red, we can make it flatten, and we can in the same way we can produce the number of beans, and we can give the color is red. So this is the red histogram, this is the green histogram, this is the blue histogram. So in this way we can do the histogram for the color image. Okay, so that's it.